Hello students, we are ready with our next video. In today's video we will discuss some reactions which were left in the previous video. So in what are the reactions which are left, we can see here this is glucose and this is fructose structure. You can see it very well. What product they form up when we treat them with HCN. When we treat them with HCN, what product we get? HCN is a product which will react on aldehydic part. HCN is a product is a reactant which will react on ketonic part and give us formation of a new chiral center. So it react on this with cyanide part and give us formation of aldehyde will change into CN and OH. So we get this OH and CN, OH and CN, the two chiral center obtained, and product obtained is called the cyanohydrin. Similar is the case with fructose. When fructose act on this will act with this negative center. It is an example of a nucleophilic addition reaction. The cyanidine will attack on CO to give us the formation of OH and CN, to give us the formation of OH and CN, and CN and OH, these are two isomers possible. Again, this is a new chiral center which is generated, and rest are same. I am just writing this as this. It means that rest are same. So this is the cyanohydrin of fructose, and these are the cyanohydrin of glucose molecule. Reaction of glucose and fructose with another important carbonyl reagent, and this carbonyl reagent is known as phenylhydrazine. Phenylhydrazine is phenyl NH2. We take excess of phenylhydrazine. What happens in this case? In case of phenylhydrazine, this attack on this aldehydic group and attack on the next carbon, and similar is the case, attack on this carbonyl group and attack on the next carbon here, and these two first carbon are involved. These two first carbon are involved in the formation of phenylhydrazine. Derivative is called the phenylhydrazone. The phenylhydrazone derivative of glucose and fructose are called osazone derivative. The name is called osazone. So what is the structure of osazone? Osazone give us the we call it is the elimination reaction. In this case, this attack on the nucleophilic addition reaction. This attack on this aldehydic part to give us the formation of this initial. After this, we get this. So the complete mechanism of this process I will explain in the later section, but I am just explaining the reaction here. So in this reaction we get these two these two carbon are involved to get this type of moiety, and here again in fructose, first CO is involved, and then this is oxidized to give us this, and we get this type of moiety. We can see here this part and this part are same in both the cases. OH, H, OH, CH2, OH, H, OH, CH2. So we can say here the osazone structure are same whether you take glucose or whether you take fructose. The structure of osazone are same. The structure of osazones are same whether you take glucose or fructose. The mechanism of this reaction I will explain in detail in the next section. But before that, it is just the reaction we should take care of this. Now the reaction of glucose, which is called the epiionization reaction. This epiionization reaction is observed when we obtain oxidation product of glucose with bromine water, which is called the gluconic acid, and gluconic acid is treated with pyridine. So let's see what is the reaction. This is D-glucose. D-glucose when treated with bromine water give us, as all of us know, gluconic acid. This is the gluconic acid, and this gluconic acid contains this acidic H proton, and this acidic proton can be removed by in presence of any base. So we treat this with a base to get this and carboxyl anion. This carboxyl anion can show us the what we call the resonance, and one of the resonating structure we get here is this. From this this negative charge can be delocalized on this CO, and we can get this diene type structure. We call this, you can see here, a ene type structure is obtained here, and this ene type of structure may get proton to give us OH, and this OH can revert back to give us this OH can revert back again to give us CHO here and H here, or CHO here or H here attack on this side. So we get this product. Again we can get the glucose from this reaction, or we can get its epimer, which is called this mannose, can be obtained by this reaction. So I'm just trying to explain, and I'm just repeating this reaction. Glucose with bromine water gives us gluconic acid. It contains the acidic proton. This acidic proton can be removed by any base to give us this enol type structure. This enol type structure can undergo resonance with carboxyl anion to give us this type of structure, and this type of structure can revert back to its initial state, and this initial state attack of this H on reverting back can be from the front side or can be from the back side. When it attacks from the front side, it can give us our again back our aldehyde, which called the glucose part. When it attacks from H, revert back attacking from the back side, it can give us a epimeric structure which is called the mannose. So we get, in this case, we get this is glucose and this is mannose. So mannose is epimer of glucose. See, you can see here these two compounds differ only at one carbon atom. You can see here only one carbon atom is differing in these two compounds. Rest are same. OHH, HOH, HOH, OHH, HOH, HOH. So rest are same. Only one is differing. So all those isomers which differ only at one chiral center and rest chiral center are same are called epimers. So I repeat again here, epimers are those isomers which differ only at one chiral center and rest carbon center are same, they are called the epimer. So glucose and mannose are epimers. So in this reaction, after getting this, we get this, and we, after reverting back this, we can revert back to give us aldehyde and HOH, or can give us aldehyde or OHH. So we get OHH and HOH. This is aldehyde, which called the initially we get glucose, and this is mannose. So this is what we call the epimerization reaction of glucose. This is the reaction of glucose with NaOH. NaOH, you know, is a very strong base. It can react on this glucose and try to extract its acidic proton, which is this, and give us this enol type of moiety. This enol type of moiety can undergo resonance with aldehydic part to give us this type of compound, which is called the ene-diol. It is diol, so it is called the ene-diol moiety. This ene-diol moiety is the, we can say, is the intermediate between formed by this reaction. It is a very important intermediate. In this ene-diol, through this ene-diol, we can get three different type of isomers. We can get glucose from this, we can get mannose from this, we can get fructose from this. So after formation of this ene-diol, I again repeat this. This is the glucose molecule. Glucose molecule contains acidic H, and this acidic H can be abstracted by base to give us this enol, and this enol can undergo resonance with this aldehydic part to give us this ene-diol type of moiety. This ene-diol, this is ene and this is diol moiety. This ene-diol moiety is a very important intermediate to give us glucose, intermediate to give us fructose, intermediate to give us a mannose moiety. But when we get fructose if base abstract this H. If base abstract this H, so we get OH negative, and this OH negative will be in resonance with this to give you CO and CH2 OH. So we get ketone here. So we get ketone to get fructose through this intermediate. So intermediate, if in ene-diol we try to abstract the proton of this OH, then after abstraction of this OH, O negative will be formed, and this O negative will delocalize its proton, delocalize its electron to give you CO CH2OH. CO CH2OH we can see here. So we get fructose through this intermediate. Otherwise, if we think of abstracting this proton, if we abstract this proton, it will give us this negative charge, and this negative charge will be showing us delocalization through this, and will show us the formation of CO positive and H. H can be attacking from the front side to give us HOH. It can attack from the back side to give us OHH. I repeat again, if H attack from the front side, we can get HOH. If H attack from the back side, we may get OHH. So HOH and OHH are nothing but the isomer of glucose and mannose. So this is glucose, HOH. Glucose can be obtained through this. If attack from the back side of H is there, so we obtain OHH, that is mannose. So we can get glucose, we can get mannose, and we can get fructose through this important ene-diol intermediate. This is a very important reaction. When we treat any glucose with NaOH, what happens if NaOH is very dilute solution? So we can observe the blackening or browning of the glucose of solution. but if NaOH is very we can say very strong, then we observe the blackening of glucose solution. If NaOH taken is very mild, solution is taken NaOH, so in that case we observe this type of reaction. This type of reaction observed in a mild solution of NaOH to observe this type of in fold formation, in aldehyde formation, in diol formation. In diol formation, abstraction proton from this to give us ketone, and this ketone is fructose. Abstraction of this H to get aldehydic part, HOH, and OH part to get glucose and mannose. So from the same molecule, so from glucose we are getting glucose, mannose, and fructose. From if you start from mannose here, we can get mannose, glucose, and fructose. You start from fructose here, again we will get glucose, mannose, and fructose. So this is a very important reaction. You can remember that whether you start from glucose, we will get a mixture of glucose, fructose, and mannose. You start from mannose, you will get a mixture of a glucose, fructose, and mannose. You start from fructose, you will get a mixture of a glucose, fructose, and mannose. So this is an important reaction, and name of this reaction, very important reaction, is called Lowry-de-Bruyn-Van Akenstein reaction. The name of this reaction is Lowry-de-Bruyn-Van Akenstein reaction. The name of this reaction is Lowry-de-Bruyn-Van Akenstein reaction, a very important reaction of glucose and mannose. So with this, so these were some of the important reactions shown by glucose and fructose molecule. So with this, we can say we have finished the important reactions. So we will meet in next class. Till then, thank you very much.